Hello and welcome everybody. We're starting the webinar right now. Welcome to our webinar today on using robotics and AI to support waste management. My name is Jana Stucke and I'm being your host for today. And I'm a knowledge transfer manager here at the Knowledge Transfer Network for Intelligent Systems. And before we start, let's do some housekeeping first. So as you can see, you're all muted. That will stay for the entire webinar like so. Also, if you have any technical difficulties, please use the chat box, which is somewhere down here. Right next to it is the Q&A box, is for all the questions that arise during our presentations, and we will answer them at the very end. And additionally, we have Meeting Mojo. The link to that will be posted shortly in the chat box, and you'll be able to log into it and book a meeting with someone you find interesting and want to talk to. And tomorrow, the 9th of October, entire day, it will be open for you guys to meet with each other. So please, if you want to get to know each other, use the link in the chat box in a minute to sign up. Now, I give you a bit of an introduction what we, KTN, are. We are the Knowledge Transfer Network, and we are here to form connections between academics, industry, and innovators. We do that in form of networking events like this. Also, we have a variety of other events. We have challenges, we have funding opportunities, and also we like that you reach out to us if you need an introduction, and we will make it happen. And yeah, without further ado, let's start with what we are all here for, to learn more about robotics and AI and their capability to support waste management. As you might have already read in our introduction to this event, there are some issues in increasing the recycling rate. And it's hard to meet the targets which are set by the government, by the MRFs. And yeah, with the rise of AI and robotics in recent years, they may be able to support this. And we are now today here to see what technologies are out here and how we can apply them. And for this, I have invited for you 3 speakers today. And the start will be made by Pree Thomas from Viridor. He's a technology and innovation lead at Viridor. And he will give us a bit of an overview and a background of what the problems are MRFs are facing and how they're currently using AI and robotics. This will be followed by Alisa Pritchard, who is head of marketing and operations at Greyparrot. And she will introduce us to the technology Greyparrot is developing for MRFs. And then we finish off with our last speaker, who is Yhap, CEO and co-founder of CleanRobotics, who has a slightly different approach and starts at the consumer level. And afterwards, we will have my colleague, Sally Beken, on it, and she will give us an overview of funding opportunities which are currently available in the space. And after that, we will have a Q&A session where we will ask the questions you pop into the box next to the chat box. So without further ado, let's welcome Pree Thomas.
Afternoon all. Thank you very much for the introduction, and I am, as is explained, here to give you a bit of a background, a bit of some of the history and how we got to here. So, recycling challenges within the waste industry. So a bit of background. This all really kicked off in the UK with the advent of the 1999 landfill directive, looking at increasing recycling in the waste industry, looking at dealing with our material and feedstock in a different way. And it drove the initial phase of development of infrastructure in the UK, looking at recovering materials and finding initially a safe home for recovered materials. And a lot of the plastics we used to deal with would end up in pipework and low-grade recycled outlets. And as things moved, we've then looked at the new challenges to try and drive this all forward and move things forward. So we start with, and we still start with now, a big pile of mixed recyclate in some cases. Sometimes it's curb sorted, comes in in different batches, but it still needs to be then further processed, refined, and in order to be recovered. So we have initial product separation. So here you can see the mixture of materials on a belt. The first stage is a manual cleanup system. This is quite often done still with manual pickers, mainly looking for non-target material in the recycling stream and anything likely to damage the further downstream process. So initially we have this manual pick, and we'll take out lots of fence posts, large metal items, anything you can get in a wheelie bin will end up in the recycling plant. And we're still getting a plethora of videotapes which contain, which break and then wrap around the rollers on the conveyor belts and cause enormous problems through the plant. And then once you've got through the first picking stage, the material is then goes through the current technology using a near-infrared scanner, which operates as very much a yes/no gate, looking for target material or non-target material, and it just extracts one from the other. So you'll either have a positive sort where we'll pick out the target off that belt, and then everything else will continue on to the next scanner, and then we'll positively pick something else off until we've got down to just the final materials and a reject line. And that gets us the first stage, and you put a number of these in sequence in order to get the quality of the final product coming up to the standard that we now need to achieve our recycling. But if you look at it in real terms, where are we? Not a lot has changed since the Model T Ford came along and they started to put a production line together, a line of people working one behind the other. And this is where we have been in the waste industry, a little bit beyond this with the automated picking systems. But in effect, we are still working as a simple production line and a single flow of material through the plant and looking at the challenge in that direction. And this kind of represents the fact that there is a way to go with automation and modernization as we're now moving towards achieving the circular economy requirements and looking to get more and more of the material around, and moving the waste industry to now look at the material we're handling and the society as it less of a waste material, but more of a transition from one product that has gone through to the consumer, gone through its life cycle. It's then been put out, and we have to look at opportunities to then recover all the raw materials from that to enable it to go back into remanufacturing to turn into a new product for a new consumer. So where's the challenge in this? Well, if you look at picking requirements and what we're looking to try and achieve from our separation systems, there are many, many automated systems out there in industry, as demonstrated by the way building of cars has changed since Henry Ford put his production line there together into the modern robots that build vehicles for us every day. Now they can do that at reasonable speed, but it's just the same monotonous movement that's required. And if you're trying to do multitasking and multiple things, then you have to drop the speed. If you want it continuous, fast speed, simple picking arrangement, against the opposite being that if we want to get quality, you really need to bring it slow. And of course, in the waste industry, we start with a really complex mix of materials that needs to be picked at high speed and has enormous variety, not just in the materials, but in the way each individual material is presented. If you imagine a Coke bottle can be crunched in 1,000 different ways. We need a system that will always be able to tell, no matter how many ways it's been crunched up, that's still a Coke bottle, or it's still food grade PET. Now, that's quite a quick challenge. It needs a lot of computing power and a lot of speed in that calculation system. So at the front end of our plants, in the bottom left, we're very complex, very high speed picking requirement, and a huge variety. As you move through the process, we're getting more into quality control, down almost to a single material. Picking speeds and occasions are lower, and the variety has dropped as well, which gives us an initial approach. And this is where the first automation systems have come into the recycling world. There are a number of developers in this area with the Zen Robotics and the Max AI coming into the system. So hopefully this will run. Talking of Macs, this is the technology we've installed at our recycling plant at Skirmsdale, taking existing system and knowledge that's out in industry. So it's a standard ABB arm, which is, there are hundreds of thousands in manufacturing already, but it's been linked to the first stage of intelligent automation, where it's scanning and picking off material off a quality control belt. So this is seeing predominantly one target material, and it's being required to pick out the non-target materials in there. And it does that reasonably well. It does it to a good standard, and it does it quicker than we can get our pickers for too. And you've got to understand that with the best will in the world, our pickers do an invaluable job in our recycling plants. This isn't the most exciting job for an 8-hour shift. 3.5 minutes of a video is okay, but this goes on for a while longer. So I'll draw him off there, and hopefully we will skip to the next one. No, yes. So I want to finish up with saying that that's where we are with the challenge at the moment. These are the things and technologies that are coming through. But as you can see, this is only dealing with our quality control stage. We need to up that speed, up the detection system, and look at what are the future challenges now. If we're going to achieve a circular economy, where do we need to be looking to get material to a quality, to a standard that it can be turned back into virgin material, raw material for remanufacturing? And it's looking at, right, how do we get advanced picking systems into the front end of the facilities so we can up the speed, up the variety? How do we improve the ability to detect and sense the material quality, whether it's by color, whether it's by food grade, non-food grade? Can we separate these materials to a higher quality to achieve a greater recovery level? And in the back of all of this, if we ever want to get to a stage of a completely circular environment, we need to be quality, quality, quality. It has to hit the quality targets. So I shall pause there as my quick introduction, and then hopefully my colleagues following will give you an indication of the future.
Excellent. Thank you very much, Marcus. Yeah, fantastic. Which then, as Marcus already said, will lead us to our next speaker, Alisa Pritchard from Greyparrot, and she will give us now hopefully some solutions to the problems Marcus already raised.
Thank you, Jana. Thank you, Marcus. Pleasure to be here. So I'm just going to share my screen. So I'm Alisa from Greyparrot, and at Greyparrot, we provide computer vision solutions for waste management. Just a little bit about us before I go back a bit about AI in general. We provide AI waste recognition software, and our aim is really to increase transparency and automation through digitization of waste. And we want to really empower waste managers, waste producers, as well as regulators with better waste data analytics. So I think some of the problems that Marcus touched on does come from a lack of data. And the aim is really to help us transition to a more circular economy. So the reason that we got here and that we can use this form of technology is because of some of the advances that have been made in AI and deep learning in the recent years. Firstly, computing power has increased, and this just means the speed at which computers can process information and make complex calculations. Second is the availability of data and the quantity of data, which is really the fuel for AI models. And last but not least is proven use cases, whether in healthcare for tumor detection or driverless cars. There's a lot of interest and investment in this field. So we're very much focused on the vision and robotics side today, but just to let you know, there's also other domains of AI. So you may have seen with Siri and Alexa, with audio and speech recognition and reasoning, with logic, such as this is the game Go, that AlphaGo by Google can beat, the world champion in this game. So we are specifically focused on computer vision software. And in the most recent years, we've seen that computer vision has actually delivered human level visual recognition or better. This is just showing the development in this field and the reduction of error rate compared to human performance. I thought it might be fun to show you what my team and I did before we came into the field of waste management. We were founded in February last year, but previous to that, we worked at an AI computer vision company building cutting-edge computer vision products. And some of the systems that we built, you can see here. So we had facial recognition to recognize different faces, as well as twin recognition. We also did auto recognition, so recognizing cars by the shape and the color to identify the year, make, and model. This was for an insurance use case to provide a quote. We could recognize logos for marketing messages of packaging. Now we're trying to track packaging to the end of life, so we're going full circle. This is flower recognition, and also, last but not least, our co-founder built this landmark recognition. This isn't based on GPS, it's based on the look, the color, the shape of the landmark. So coming to waste management, we thought, how can we use this expertise and all our passion in this field to translate it to waste management and to provide a social impact? And our first prototype that we built last March was using 10,000 recyclable images of different dry mix recyclables. And we integrate it into this sorting robot. This is just a demo. This is not a working product, but just to show you our first prototype. So using a simple iPad camera with our algorithms, we found that actually this is transferable to this field, and we could recognize different types of plastics, different types of fiber. And here is a robot at Middlesex University that we integrated with to just show our integration capability. Before I show you kind of concrete examples of our technology within the MRF, or the material recovery facility, I thought just to spend a couple minutes explaining to you how this works, because I know it looks like magic, and even to me, it feels like magic still. But essentially, we use a technique called deep learning, and this is really the use of models called neural networks, and they're comprised of many layers, as you can see here. So each layer is trained to recognize something to make an intelligent decision from known samples. So known samples are these images. So we feed it with maybe 1,000 images of a PET bottle in different shape and sizes. And finally, it will learn that the next time it sees a different bottle, even if it hasn't been fed to it previously, it can generalize. So it uses these different layers to identify light and dark pixel, edges, features, combination of features, and then eventually coming out with the output. So within AI and robotics and waste management field, I think Mark has alluded to some of the issues as well in this industry. And for us in particular, we were really interested in solving the issue of a lack of data. So you can see here these bales of material, the material coming in. There's very little information about what's in here, what's on these belts, what ends up being sold. And a lot of this is manually sampled and also sorted. So it's quite an interesting area because it's highly engineered, but I still think there's a lot that can be done to improve this process. So when you look at sort of the life cycle of waste, from collection to transfer to processing, there's really areas where computer vision can add value. So when you look at the collection side, we luckily have the CEO of CleanRobotics here to talk on this today, but computer vision can be used to identify materials at source to be sorted in a way that provides better feedstock for the MRF. Currently, we're experimenting with integrating our software system with a next generation reverse vending machine you see here. This is based in South Korea. And Marcus, you already showed this video, so I don't need to, but this is the sorting robot that is being used in facilities. I just wanted to also extend the word robots to also mean these sorting machines, which are optical sorters, and they can be using air jets as well. So robot doesn't always have to be referring to, the one that looks like a human. It can also be the machines that are currently in the facilities. Now coming exactly to what we do at Greyparrot. So the way that we're introducing digitization of waste is we're trying to move from this highly manual process, which literally involves a person standing here and counting the waste and weighing it to provide some level of information to the facility about, you know, what waste is coming in. Is it contaminated? Do we need to send it elsewhere? Or to give quality guarantee for buyers. We are looking to replace this process with an automated system. And our solution is this. So it involves an automated waste monitoring system, which has a unit and an AI vision model that then takes the information this unit is processing and then puts it into the data analytics dashboard. And this dashboard can allow dynamic machines, so adopting or adapting machines to the parameters needed for that composition of waste, pricing by quality, so increased transparency in that way, and also certified waste flows. A secondary focus for us is also building our systems in such a way that it can also be used in other hardware and machinery. And we're always happy and open to talk to partners who are looking for this visual capability. Just to show you in further detail, so the monitoring system, it has an RGB camera, which is fairly affordable. It doesn't use infrared or any other technology like that. It has a processing unit, lights, and frames. Our AI vision system at the moment can identify different material and object types, including fiber, plastics, and alloys, as well as brand recognition, and also make estimation on the weight. And I thought instead of just showing you a big dashboard, I would extract some of the information from our dashboard. So this is an example of what we can measure from a residue line in a facility. So as expected, and as you would want, it's a lot of general waste and fines. So residue line is a line that goes to landfill. And however, there's still some fibers and plastics and metals, and this is money lost to the facility. So you can see as how much detail we can get into and how this could be information that's important to the facility. I'll just give you quick 4 project examples before I end. But this first example is our work in South Korea. So on the left, you can see this gentleman pulling out impurities. And on the right, you can see our system is mimicking what he's pulling out to then provide a quality guarantee and also inform the facility of their performance. In the future, the XY coordinates from these bounding boxes could also be provided to a sorting robot. Second example is in the UK. So this is monitoring the residue line, the example I just showed you as well. And basically, when the count of paper reaches 100 or more, an alert can be given to the facility so they can act in the moment to capture that value. This is really exciting. We did this 2 weeks ago. So this is our new project to help identify brands, SKU level, so stock keeping unit level. And brand identification is really important for EPR, which is extended producer responsibility. But I think also, Marcus, you mentioned, you know, food versus non-food grade plastics. And I think this could be a way to also help identify that. And last but not least, this we installed last week. We've had a very busy month in Italy. And it's also recognizing material at the PET line to find any impurities. For example, that fork is an impurity. And we're looking to actually install the system at all of the lines here, the different plastics line. So to summarize, our monitoring unit really can sort of be used throughout MRF to provide more detailed instant information about the flow of waste, whether it's incoming or material line or the residue line. And yeah, so that's sort of from our side, from Greyparrot, but I think kind of zooming out from an AI computer vision perspective, I think it could really make a difference to how we value waste, the flow of waste, and how we can increase the efficiency of capturing this. So for me, it's a really exciting time for us to be in this industry. You know, it's not just about reduce, reuse, recycle, but also reinventing the system. Thank you.
Thank you very much, Alisa. That was a great talk. And as you already mentioned on your last slide, the smart bins, that's a good opener for our next speaker, Charles Yhap, the CEO and co-founder of CleanRobotics.
So maybe we'll start off with a little something. I think Marcus and Alisa did a really great job of painting a picture around the crisis that's kind of facing the recycling industry. And it's pretty severe. This is just kind of a joke I found on Twitter that US officials are urging Americans to sort plastics and glass into separate oceans, right? And kind of the crux of the problem is that human beings get confused about where to put their waste. And as Marcus highlighted, I think in stark contrast is that it's causing massive contamination at recycling plants. And the issue is that it's very difficult to sell contaminated recyclables. You know, we've heard about how artificial intelligence and computer vision at the industrial scale can help improve quality. And you know, we started our business thinking that the quality problem should really be tackled even earlier than that. If you think about it, the recycling industry is almost the only industry that I can think of that relies on the public, you know, untrained folks or folks that are maybe apathetic or maybe well-intentioned but make mistakes to really control the quality of the inputs that go into the plant. You know, one of the sayings is garbage in, garbage out. So we really need better ways to manage that the quality process. So we've created TrashBot. It's a system that uses artificial intelligence using the computer vision technology that Alisa articulated so clearly, and robotics to detect waste as you throw it away, and robotically separates landfill or residual waste from compost and recycling 300% more accurately than the public or than human beings. And we're also able, from a value proposition point of view, to help facilities save on waste-related expenditures to the extent that landfill waste is more expensive than compost or recyclables. And they're also able to reduce their vulnerabilities to fines. We're able to immediately improve their sustainability and impact. We're able to capture very granular data, and this enables waste audits and analytics that aren't possible with manual means. And the really interesting thing is that we're price competitive with classic waste stations. And we also have a built-in monitor that can be used for educational initiatives, and it can also be used for marketing and corporate communications. So this is a quick video of how our standard TrashBot works. It has dual sensing chambers. You just deposit an item of waste like you would into a normal bin. The system, the artificial intelligence will detect and classify that item, and the robotic component just drops it into the correct bin. It's really that simple. So, you know, you might be thinking that this robot sounds really expensive compared to a normal waste bin, but, you know, we're targeting types of facilities where they have a lot of foot traffic already, and they're already spending significantly on waste operations. So medical facilities, commercial buildings, transportation hubs, university institutions, stadiums, things like that. So this set of waste receptacles on the left is actually from the Denver airport in the United States, and it costs $3,000 a set. And they have 250 of those stations. So when they bought them, they spent $750,000 on shiny metal tubes. Facilities are also spending on waste audits. It's a very manual process where a team of people will basically dig through dumpsters, open up trash bags, weigh items inside of the trash bag, put that into a clipboard, and then give that to a facility manager that then has to put that into Excel to generate a report. And facilities are also spending tens of thousands, if not hundreds of thousands, on hauling costs and fines. One Chipotle, it's a Mexican themed restaurant in San Francisco, was fined, you know, 6 figures just last year for improperly separating their waste, their organics from their recyclables. So these things can get pretty punitive globally. The global waste industry is pretty huge, and I think the picture that Marcus and Alisa painted kind of indicates why it's so big. It's an industry that's overdue for aggressive innovation, and the smart bin market, which is where we play, is projected to be 25.7 billion in the next 9 years. And we think that about 30% of that can actually be in Europe. There's a lot of opportunity for innovation there. So our system is collecting data on every single item of waste that goes through it. Alisa mentioned the capacity to recognize logos and brands and how powerful that can be for extended producer responsibility, as well as the theme of circularity and closing the loop that Marcus touched on. Getting data is really the first step in enabling smart cities and building smart infrastructure, and also enabling smart enforcement and regulation. And by the way, we're semifinalists in the IBM Watson AI X Prize. So all of these claims and the visions around the capacity for the data that we're collecting, as well as other innovators like Greyparrot, has been vetted by a third party. And here's kind of, I think this is actually a good combination with the way that Greyparrot presented their summary of data. We'll actually present the dashboard, and I think this is cool. So we're collecting fullness indication on every trash pot inside of a building for the fleet, so we're able to optimize custodial operations there. And this is kind of the fast forward here to my favorite chart, where we're able to really break down in a granular way the specific composition of the waste stream inside of a building. So we're able to tell you, out of the plastic that you saw in your building, 83% of that were bottles. And then digging deeper into the analytics, we're able to tell you what percentage of those were too contaminated to recycle, and so on and so forth. If you kind of combine this data with the next chart, which is a projection of costs per ton of landfill, and how much money you could conceivably get back per ton of recycling. Now you have information with which to craft data-driven strategies to reduce your landfill footprint and actually have an impact on your bottom line. This is an example of data-driven educational strategies that we can implement. So again, using the water bottle or the plastic bottle example, this is an actual case study. We were able to dig into this client's data and determine that the biggest driver for contamination in their landfill stream was plastic bottles with too much fluid in them. So we were able to craft educational content to address that specific contaminant. An interesting thing about education with recycling in general is that it's very often one size fits all, and recycling regimes vary very much from one city to the next. And this is kind of true globally. To just use an American example, San Francisco, the city, has 8 neighboring counties, and each one has slightly different rules. So if you work in San Francisco, but you live in another county, and maybe you go to another county for entertainment, you've already encountered 3 different recycling paradigms. And it's 100% likely that you're making mistakes in all 3 because you think that the rules are going to be the same in different places. So one thing that we think about from an educational point of view is do no harm, right? We want to make sure that the education we're positioning in public places is applicable everywhere. And that's kind of one of our core philosophies around that. Our technology obviously has implications for the United Nations sustainability goals. Specifically for climate action, there's a direct relationship between recycling and carbon abatement because it's less carbon intensive to use recyclable materials as inputs versus virgin materials, and obviously implications for responsible consumption and production. The technology also has implications for clean water and sanitation, sustainable cities and communities, industry innovation and infrastructure, as well as creating partnerships for the goals. One of the things that we're really excited about, we recently went through an impact certification process with Impactable X, and we were able to determine that over the next 10 years, we will be able to abate 11.7 million tons of recyclables. And again, it's a 5-to-1 ratio for 1 ton of recyclables, 5 tons of CO2. We'll be able to abate 58.5 million tons of carbon over the next 10 years. And that will be a combination of forces. Number one, obviously improve sorting at the point of disposal, but importantly also with education, because education is really going to be a really important thing. Most of an individual's waste is not generated in public places. It's mostly generated at home. So technologies like ours, like TrashBot and adjacent technologies, have a lot of potential in the United Kingdom and Europe. During COVID, fullness indication is a really valuable thing that can add value to operations, specifically because custodians are the unsung heroes. One thing that we found is that a custodian's workload has quadrupled during COVID in terms of hygiene, sanitation, and disinfection. And what you don't want is valuable sanitation time being spent checking bins that don't need to be checked. We found that only 20% of bins in a large campus need attention at any given moment. And so you really want those custodians not checking those bins when they don't need to be. Instead, they could be sanitizing. We also think technologies like ours can be helpful in public places where you have a lot of foreigners passing through that aren't familiar with those local recycling rules. And consequently, they're making mistakes and causing contamination, impacting operations like Greyparrots and Viridors. And then we also firmly believe that the data that technologies like ours can collect at the point of disposal can be instrumental in driving education, policy, and crafting incentives that will then further drive behavior change and improvements in habits. That's all I got for you. Here's kind of the evolution of our technology. We're actually on version 5, which isn't shown in the picture. Thanks for your time, everyone.
Excellent. Thank you very much, Charles. Slight change in plan. I think it's better to jump right into the Q&A right now. So maybe if the speakers could unmute themselves, put the video back on, and we get started. And I think I feel like we should start with a little icebreaker question for Greyparrot from my side. Alisa, how come you call yourself Greyparrot? Name seems really counterintuitive.
Yeah, thanks for asking. So the African grey parrot is one of the smartest birds in the world. Not only can it mimic sound, but it can mimic behavior using sight. And because we're in the field of AI, we thought, let's refer to something like that that's trying to mimic human behavior. Plus, we're dealing with a nature use case, so we're looking to nature for inspiration, mainly because it was available as well.
That's a great reason, actually. I think there's another question, actually, probably for you, maybe also for Charles. What would be the impact of converting, the mostly manual operations at the moment at an MRF to fully automated processes on employability and human well-being? Will the robots take over, basically? What do you guys think as you are working in that space?
I actually think...
Go first. Do you want to go first?
No, you go first.
Okay, yeah. I don't know if this is true in the UK, but I would imagine that it's pretty close. The turnover on a recycling line is something like 60% every 30 days in the United States. So you have this huge turnover from people that are picking waste on the assembly line. And there's basically a whole operation to maintain staffing on that picking line. So what that means, from my point of view, is that this is a very hard job and it's a very unpleasant job and people shouldn't be doing it. From a employment replacement point of view on a robotics side, the ideal sweet spot to employ robotics is if a job is dirty, dull, and dangerous. And I can't think of anything more dirty, dull, and dangerous than segregating waste and trying to clean that mess up. From a health point of view during COVID, I don't think it's ever been as important to really figure out ways to automate and take human risk outside of waste management. And so ideally, you wouldn't have people segregating waste. It's kind of like my point of view. It's just like a dangerous job that most people aren't cut out for. Yeah, it's kind of my synopsis.
Great. No, I totally agree with that. And I think just to add to that too, if you're looking at building the MRF of the future, which is more digitized with dynamic machines, you're going to need people to do something with that data. So I think it's actually going to introduce more sort of jobs that are using our unique kind of human intelligence to operate the MRF rather than something that a machine can easily do. So I'm hoping it'll introduce more kind of higher level functioning suited to human jobs.
Any thoughts from Marcus' side, as he has at the moment a lot of co-workers in the facilities?
Yeah, we have lots and lots of people working on picking lines, and as my colleagues have already said, it's not the most wonderful environment to work in. It has its own challenges, and from our point of view, we see it not so much as a replacement, but an augmentation. If we take them out of the particularly dirty and challenging environments, then we can need to redeploy staff into maintaining the robots, the operations on the site, maintain the site, and also look at added value opportunities where we can recover different materials to a better grade, and looking at opportunities for remanufacturing and new industrial challenges. So it's more of a staging post in future development.
And what are you guys thinking with regards to biodegradables and bioplastics? How is that affecting the sorting side of things? How easy is it to detect for an AI these new kinds of plastics? And what is it from the point of a MRF facility? What do you guys think?
Shall I start with my opinion on biodegradables? Is that so long as they're detectable and there's an obvious way of picking them to remove them from the recycle stream so they don't end up as a contaminant in the product, that's fine. But also we ought to consider where the appropriate point of deployment is for a biodegradable material. The carbon requirement to make biodegradable plastic is higher than the carbon impact of making a standard plastic. And that's partly because we are very, very good at making plastic really quick and really easily, and it's recyclable. And therefore, a lot of what we should be looking for biodegradables is, rather than potentially mixing it with food, and quite often they then need to go to a compost solution rather than current policy in the UK is about anaerobic digestion, where they become a contaminant again, is to look at where we have multi-layered materials which are non-recyclable, and we're looking at energy recovery as the only outlet for them. That's probably the most appropriate place for bio-based plastics.
Yeah, I mean, I think for us, from a computer vision perspective, it's very difficult, or even traditional machine vision to a degree, difficult to recognize the difference between like a veg plant-based PET bottle and a PET bottle that's made from oils. So, you know, I think a lot of thought needs to be put into this, because if the system is not ready to collect and process these new types of materials, it could actually cause more harm than good. But if there are composting sites available and ways to extract energy from these new materials, then the collection system needs to make sure that it's going to the right place as well.
Yeah, I totally agree with my colleagues. And, you know, the way I usually think about it is, you know, it takes an ecosystem to make this work. There's no magic bullet. You know, from a trash bot point of view, we're able to cheat a little bit. As Alisa mentioned, it's hard for a computer vision system to tell the difference between a biodegradable plastic or biocompostable or digestible plastic versus, you know, normal plastic. But because the waste that we see is at a facility level, and facility managers are able to make purchasing decisions, and we can calibrate RAI for those purchasing decisions, we can make accurate distinctions between those types of plastics and everything else. But it does kind of go back to the point, if there isn't an ecosystem that is dealing with that specific type of stream, it's going to be a contaminant by the time it gets to a plant. And so you really need, at a facility level, a waste management regime that is separating residuals as well as recyclables, and then bioplastics or biocompostables or biodigestibles. And if you don't have all that, it's not going to work well. You might think it does, but in practice it won't.
Excellent. Now a bit totally unrelated question to that. What are the current challenges in implementing robotics and AI technology? And if there are any, how can project management expertise help and in what way? And I think that goes to Marcus actually.
Challenges at the moment are we need multiple different solutions for different stages of the production of the treatment process. As you've seen today, we've got two completely different solutions working at different parts in the process. It needs more than that. They need to be adaptable, and as my colleagues have spoken about, it's as much as anything about the ability to do what a human brain does very quickly, is analyze an enormous array of data and then pick out key indicators along the way of what the material targets. We don't actually read the labels when we go shopping. We quite often think of the color that we've got in our mind of the bottles. So you'll pick on color rather than on what it says on the label, and you do the same thing in the picking line. It's the ability to pick up small indicators and then react really quickly.
Awesome. Are there any views and on AI data opportunities in recovering glass packaging? I'm not sure who could answer this, maybe also to Marcus?
Yeah, there is certainly opportunities in glass. One of the issues we have is a lot of glass sorting is done by optical vision on color. So we separate the browny orange color from green from clear. The issue we have is a lot of glass is collected from mixed recycling facilities, and when it's collected at the front end as a rough aggregate below 40 or 50 mil, but it also collects all of the bottle tops off your plastic milk bottles, and when we come to sort it at the glass plant, you end up with all the green milk bottle tops ending up in the green glass because it's looking for green. So an additional stage to remove or pick out contaminant material from that is a challenge that's out there. And we've looked at numerous different ways of floating off the plastic or washing it, but there is opportunities for an intelligent picking system in there as well.
On that note, what do you think on how automation can address like the contamination of materials? Let's say someone throws away a half full glass bottle. I think Charles' system has actually something to figure out if it's half full or something. But yeah, how is that addressed, or can automation help there?
I suppose the biggest challenge with the automation is we can spot it, but what you do with it, it's once it's gone into the system. If it's been put in half full of Coke in a Coke bottle, currently it'll just bounce through on the belt. It won't be blown off at any stage because it's too heavy, so it'll end up in the reject line. If we identify at the front as a contaminated bottle because of the volume of liquid in it, it's still going to end up in the reject line. This is more a thing we need to do with, as Charles said, the education at the front end to pull the liquid out of it before it is put into the recycle system.
Okay. Yeah, sorry. I'm just overwhelmed here with all the questions I have to sort.
Actually, just to comment on the contamination side, I think one of the projects I've seen that's given me the most hope in how to fix this issue is in Ireland. It's quite a privatized system, and there's a big incentive for them to sort of get the collection quality right. You know, they own the whole chain. So what they've done is to place a camera inside the collection truck, and before the rubbish gets compressed, a photo is taken. That photo is linked to the RFID tag of a bin. An automated letter is sent to that household to say, you've put wires into the green bin, this is not allowed, or you've put glass, because they're not collecting glass, you're not allowed to put glass in, or we see a closed bag, it has to be loose waste. And after the third time, they get a fine. So that's quite a strong incentive to, you know, not only are they giving targeted feedback, but also they're finding them. So this is like the stick approach. But I think there's another approach of maybe rewarding councils that are recycling better, or even by building. And and I mean, I think seeing a photo of the stuff that you put into the bin and being called out on it, there's real power in that. It's also, some people don't know. So having these warning letters is very powerful and educating.
Yeah, that's a great example, Alisa. And it's a great example of kind of the stick approach, maybe an example of the carrot approach. We're working on a partnership with a company in Singapore, and they've built an app that incentivizes good waste behavior. So you take a picture of your item of waste, and it's able to determine, you know, where you should put it. And it automatically calculates the carbon abatement for correctly depositing your item of waste where it should go. And you get credits for ride sharing. So in Singapore, they don't have Uber, they have Grab. So you get credits for Grab or for the grocery store or for public transport. And so I think that type of incentivized model can have really powerful impacts.
Mm-hmm.
What do you guys think about, like, let's say, cross-sector value of your technologies, as in using it maybe for repairable and remanufacturing items, or yeah, identifying and separating reusable products in general?
Remanufacturing, repair of
No,
what?
like if you use that basically on like, let's say, I suppose this question means, yeah, can you put it into a different sector? You know, when you identify items which are still reusable, I think it's like motor blocks or something from a car, or sometimes they can be reused. Would that also be like, could your technology also be retrained, I suppose it is, to identify like other items, or to maybe see where there is a failure in it, and yeah, or used for nuclear waste or something like that?
Yeah, definitely. I mean, if there's enough images and they can be labeled according to what they need to be characterized as, then, you know, computer vision, that's what it's made for. There are companies that look at defects of products on a conveyor belt, and defects can be, you know, many different types of, it's not always consistent, and computer vision can be used for that. I think also there's a company that specifically looks at damages to cars to then provide like an insurance quote, you know, if you've damaged the car too much or too little. So yeah, it's actually really, there's a lot of use cases for this.
Excellent.
Yeah, I was going to say, when we did our first assessment of automating visioning and sensing technologies in recycling plants about 6-7 years ago with the universities, there was a lot of light interest from the universities at the time that getting into waste, it was like, well, it's bits of rubbish, you just sort it out. Until we got the academics to walk around the site and look at the challenges and what they were doing that they thought was far more highbrow in manufacturing side of it, the realization that we had in the waste industry a really dynamic system with a lot of variability, massively changing rapidly second from second, with a high degree of mixed materials that have a huge variety of presentation. If they could crack this, it would make automation in many other environments a much, much easier proposition. So it went from being a low interest to quite an academic challenge. And off the back of that, it's great to see technologies coming through, such as the Greyparrot, Recycle, the automated bin systems. It's just wonderful to see these now coming through the system.
I think I have another question regarding the fines that we mentioned earlier. What is your guys' opinion on, should we have DRS for all products instead of just on-the-go products, thus incentivizing the consumer to recycle better?
Issue with DRS is it's got to be a balance of what you're trying to do with it, because if you're asking for a DRS system to return to work, someone has to return it. So now you're asking all the members of the public to bring back everything individually to be collected and put in a bin, and more, which means everyone's then driving with their rubbish themselves, or you send out a single collection vehicle to do a whole round and bulk it up in one go. So I wouldn't say it's the ultimate answer, and we have in the UK a very good collection system already in operation.
I think I can comment actually more about South Korea because that's where we're working on using our technique in the DRS there. I think that the issue is you're still relying on sort of consumers to not put in a full bottle, and there's still that consumer element that you need to kind of tackle. And I know there's barcode and there's weight, but I think there's, from a technical perspective, it's not completely foolproof and there's still a few things to work out. Actually, Charles, maybe you know more about this in the smart bin area.
Yeah, I don't know. I don't have a ton of experience with DRS, actually. But in general, it goes back to it takes an ecosystem to make this type of regime work, and there's no magic bullet. If you have that implemented and you've taken a systems approach to consider, all the failure points, it's a good option. But it really does take an ecosystem.
And then there's, I think, a question probably more for Marcus. Yeah, are the residuals or liquids attached to the plastic considered as a contaminant? And do they affect the quality of the recycled plastics? And if so, how do you get rid of these contaminants?
No. Short answer. No, small amounts of contaminant on the bottles is not an issue. Once we get them through the process to be sorted to a single material stream, it'll then go through a wash process before it's turned into flake and prepared ready for remanufacturing. So we do wash off the small amounts of contaminant that are still in there. It's if you've got a half bottle with the lid still on it, it just won't get through the process to the washing stage and the shredding stage. We'll have lost it before it gets there.
Awesome. I don't know, I think that's an open question.
I could just chime in real quick. It depends is the answer in my experience. Some facilities can handle more fluid than others. Some of them can handle bottle caps, depending on how they have the line set up, and some facilities can't. So it really depends, and this is why it's such a challenging thing to do the right thing.
Okay, so for the next question, are any of you guys experiencing any resistance from the target industries? And if so, what are the barriers we need to overcome to have these technologies widely adopted?
Is that us objecting to these technologies? Or
you can speak for Viridor if they are like reluctant to adopt.
I don't think we're not, certainly not against the deployment of this type of technology. We're actively encouraging it to develop. But the challenge we have from our side of it, what we're driving out of these technologies is, as I finished up with on my presentation, it's all about quality. If I'm going to get these materials back into the remanufacturing to go back to the customer, it needs to be of the quality at or about virgin grade material.
I think the margins within waste management are quite small and tight. So I don't think every facility will have sort of an R&D budget, especially you're kind of just trying to make it work, and it totally depends on commodity prices, and even COVID has affected some of the paper recycling plants we work with. So I think when you're working with such tight margins, it's also, if you're a smaller company, it's hard to kind of put money aside to invest. I think that's why we're really trying to have low cost hardware and smart software, because we know each unit, if we want to put 10 in a facility, it can't be costing, 10,000 or more, because it's too expensive. So I think these technologies also need to become more scalable in terms of pricing and kind of work within the system, not have them have to kind of change the whole process just to fit in your one robot, or it takes two. But I think this industry is sometimes seen as like old school because it's a very traditional industry, but I think the fact that it's so engineer driven, it's actually been quite easy for us to have conversations because it's all about optimization. So if the price is right, it's been good so far. Fingers crossed.
Talking about it's an old industry, and you guys are all quite young. Yes, you, Marcus, too. How did you guys
Thank
get
you.
into it? How did you guys get started? How did you get fascinated by waste?
Actually, I don't know that. I know Charles for a while now, and I don't know this, so I'm interested to hear.
Oh, all right, I'll go first. So, yeah, I'm a serial social entrepreneur. So I get involved in organizations that have double or triple bottom lines. This is my fourth social venture, and this idea was basically born of frustration. So if you've ever been to a Whole Foods or something like that, and you go to deposit your item of waste, let's say you go to the hot bar and then you want to throw your stuff away. To this day, I'll still have the experience where I'm confronted with the array of bins, and I'm just like, I still don't know where to put this stuff. And I'll look at the signage, and I'll think, man, you need a PhD to get this. Like, why do I not get it? And then we started looking at the diminishing cost of sensors and robotic components, and AI's algorithms were becoming increasingly accessible and commoditizable. And we thought, maybe we can build a robot that does this better. And that was back in 2015. And we thought it would be really easy, and it turned out to not be so easy, but we just kept working at it, and here we are.
Yeah, and now you're like the world leader in it, so definitely worth taking the journey. So for us, we founded Greyparrot with the idea of taking this expertise and using it to make a positive social environmental impact. And we were online, and we went on this website called Kaggle, and there was a competition on, they basically post computer vision challenges. And there was a data set of recyclables, and we downloaded it and tested it and thought, oh, this is not too difficult for our expertise and to recognize. Then we sort of did this MBA deep dive into waste management, and just were completely blown away by the opportunity and how underserved it was. Everyone in AI is like chasing healthcare and agriculture and these other sexy, exciting areas. But we found actually waste management is even more exciting. There's the deeper you go, I think you just don't want to leave this field. I think when we started too, there was the ban on exports from the West to China. So suddenly there's this influx of materials that needed to be processed in the West, and it was being sent to Southeast Asia, and they didn't want to take it. So there was this increased demand. And then also the recycling targets, 65% by 2035. We thought, okay, there needs to be an improvement in the efficiency. And then all the corporates, I mean, you've seen the Coca-Cola ads, like, recycle our bottles are recycled. They haven't changed anything, but there's this huge like consumer demand to recycle, and it's now a marketing message. So we're like, yep, this is the correct time to enter this industry. And luckily, being in the industry, we really like the people too, having come from sort of a marketing retail. No offense if anyone's from that industry, but we much prefer working with people in waste management. It's been really fun.
And from my point of view, I'm a chemical engineer by training, and chemical engineers spend their entire life building stuff. And I like a challenge. And I looked at the waste industry as an opportunity to demanufacture everything anyone else has ever made. And it didn't then restrict me to just being in oil and plastics, looking at glass, looking at metals, organics, liquids. I have the whole world of anything anyone can make, I've got to disassemble. And it was quite a challenge.
Yeah, I think there's definitely something in like turning waste into a resource. Like that really appeals to me. Everyone's throwing things away, and now you can actually turn it into something that you actually not only make money from, but you protect the environment. It's, very motivating area.
On that note, did you have a look at chemical recycling yet, any one of you? And how
we have been
Yeah.
we have been looking at it for a number of different opportunities, for looking at the non-mechanically recyclable materials. But again, you're looking at so with plastics, we've got the recycled material that we want, that's mechanically recycled. We then have the section of material that's monoplastics, relatively easy to crack or break down and recover chemically. And then you have a batch beyond that that's the multi-layered, multi-bulk material that's got layers of different types of plastics, foils in there, it's got additional material in there that doesn't fall into that category as well. So we're looking at a cascade of different technologies, of which chemical recycling is again one of those.
Yeah, there's definitely a use case also for this technology in chemical recycling. We're sort of tackling one beast at a time, but that's in our roadmap.
Yeah.
And on that note, Marcus, I think it's more for Marcus actually. So we have here a very interesting phrase question. So assume Santa Claus would be a representative of a university. What would your wish list for him be? So what should universities do, or how should they engage maybe in helping MRFs to increase their recycling rates?
Universities that I've been working with are all very keen, and now far more in the last 7 or 8 years, it really has been a difference of opinion and approach. There are a lot of people coming into the industry that are approaching waste as a commodity, as something to look at, and there is definitely a far more enthusiasm for finding new systems, new approaches, new technologies, new materials that we can use and recover. So whilst you get your normal academics, you also get a lot of people coming through the system now that are quite entrepreneurial and are looking to help to find the solution to the circular economy.
Yeah, I guess that's why so many companies spin out of university as well, right?
Yeah.
On another question, how does like Charles and Alisa, how could you imagine that you could use your applications for textiles as well? Because there's obviously a strong issue with regards to sorting.
Yeah, we get asked for everything and anything, you know, textiles, construction and demolition. I got asked if we can recognize like golf clubs. There's a number of use cases, definitely. And I think textile is one of those industries that's, you know, even worse than airlines in terms of carbon emissions. At the moment, we're really focused on dry mix recyclables, but there's no reason we can't extend the definition of waste to include textiles. It's just not something we're doing at the moment.
Yeah, we're not handling textiles right now either. And textiles are really complex. There's all kinds of materials that go into textiles, and it's very difficult if you're just using a RGB camera to distinguish the different types of materials. You'd have to use different types of illumination and different types of sensors to even begin to like create a database around that. So it's not a straightforward problem from a computer vision and an AI point of view, and it's also not hardware light. So it's, from a business point of view, it's very challenging as well. It can be, I mean, it's not technically impossible. I wouldn't say that, but there are real financial limitations to a near-term solution for that industry. It would take someone very dedicated to kind of like attack that problem, but it deserves to be attacked. It's just not us right now.
I think an easy way, oh, sorry. Just to add to that, I think an easy way to know where sort of AI computer vision can actually classify things is to look at, you know, where is it that human vision is needed to make a split-second decision? Just human vision, not lifting it up, not touching it. And if you can look at a picture of a cloth and say, this is this type, this has, you know, 50% plastic in it, then computer vision can do that. But I think a lot of times you need additional sensors other than RGB cameras. So there are limitations to this technology, but I think if you're using human vision in any process to make a split-second decision, computer vision can do that. And it can do it at a low cost because you're using low-cost cameras.
Yeah, that's I think also that's why you have I think for the sorting of the textiles you always have human hands. They do a lot with their hands, so you need to model the tactileness of a finger. Yeah. So I think this one is for Marcus actually, but maybe others have a comment too. How was the collaboration between the waste producers and those who have to process the waste afterwards? Is there anything?
I think this comes down to the understanding of what is recyclable and what we are looking to receive, which takes you back to what Charles said earlier about every authority has its own specific collection routine. It's got a different mix of material, and trying to get a system where the public has half a fighting chance of putting the right things in the right bin would be a good start. We did do with a lot of our treatment areas a lot of work in the past with public awareness campaigns about what goes into the bins in a certain area. But that work was driven through the local authorities as our client, and their budgets have been constrained somewhat since 2008. And we've seen since then a slow drift in that the contamination levels have slowly crept higher and higher. And that is impacting on our ability to achieve the quality without slowing down the way we operate the plants. So it's a multi-pronged attack that is required. But the relationship between us and the consumer is an understanding that we understand that the information they're getting is scarce and it's a challenging place to be.
I think we should round it off now because we've spoken for quite a while. So I have a final question. What are future opportunities, you think, for AI and robotics in the waste management industry?
I have a lot of thoughts about this. I think you can apply AI or computer vision or data aggregation and analytics or robotics anytime an item of waste or a bunch of waste changes hands or changes containers. So level of the waste bin where we play, at the level of the dumpster, at the level of the dump truck, at a transfer station, at a recycling plant, at the end of a recycling plant, in apartment buildings, high density housing or office buildings. Any of these locations, there's an opportunity to learn something about the waste stream and make valuable decisions based on that, on those learnings. So I think there's a lot of opportunity. And when I said, the $435 billion a year industry figure as part of my presentation, I think once people get wise to the potential for innovation for these types of technologies, it's the 435 billion is going to seem quaint in retrospect.
Yeah, I think waste is increasingly being seen as a valuable commodity, which is what is going to drive these innovations and technologies being adopted, which is really promising because I look at packaging so differently now. Being in this industry, I wash and I'm amazed at how well made it is, and I know where the materials come from. And for me, it seems now crazy to just put that in general waste into landfill. So I think the more people are on board with this, the more you'll see these technologies being adopted and supported.
I think it is, from my point of view, all about the data. The ability to understand what the material is and turn it around. Having that data, I think the simplest way of putting it is, as I said before, we are a demanufacturing industry. But if you look at it from the point of view of trying to claim that you're an industry, we are the only industry where we have absolutely no idea what our feedstock is from one moment to the next. And then you're trying to run a quality production line on the basis you've got no idea what's coming through the gate.
Okay, thank you. Yeah, no, go for it.
Sorry, this is why I'm so impressed that things have worked, because this is exactly, we've known less than 1% of what's coming in, but you still managed to make it work. I think also in the future, there's a lot of talk about kind of decentralized systems where, you know, you see these trucks traveling, gathering waste from every building, then going into a central location. But I think technologies like what CleanRobotics has, potentially ours, you know, maybe more flexible sorting robots, maybe you'll see it within your commercial site. So there's not waste traveling around and, you know, the trucks everywhere and the pollution from that. And it's just being valued and sorted properly by residents and then sorted at the spot to then be collected and reused.
Okay, I see there's still more questions coming, but I feel like I need to give my colleague Sally a bit of the opportunity to speak of where the money is, where people can find it now. So I think you guys can also see the Q&A box. So if anyone knows the answer to one of the questions, feel please free to answer them in there. And already, thank you very much for being here. I will now hand over to Sally and tell you more of current funding opportunities.
Oh, thanks, Jana, and thanks to all the panelists. I found that absolutely fascinating, and I have to agree with the sort of the last feeling that valorizing waste is something that's going to be a massive pull. I mean, if we're going to meet our climate obligations, we can't keep extracting materials of any sort from the ground, whether it's a fossil fuel or a mineral. The mineral requires fossil fuels to extract as well, and our planet will warm. So the stuff we've already extracted and is out there is really valuable to us, and we should be, yeah, sorting it, identifying it, and making it into something new. So, right, okay. The good thing is that's also recognised by government, and so there's a fair amount of funding going on. Thanks for everyone for staying on. I work at the KTN with Jana, and the majority of my work is focused around plastics. I'm a knowledge transfer manager in plastics, and I've been doing the role that I've been doing, facilitating and knowing the plastics community for about the last 17 years. I'm currently running something called the UK Circular Plastics Network, which is hosted by the KTN and funded by UK RAI, so UK Research and Innovation. And they have a lot of funding available, but they aren't the only funding organisation where you might find something to facilitate what you're doing. And I have lots of conversations with individuals and larger organisations who want to make a difference in this space. The AI part of it is not my area of expertise, but I think it's a real enabler, because as Marcus said, without the data and without information, we're not going to be able to solve this hugely complex system. My background is in formulating rubber compounds, and actually there's a lot of ingredients and formulation products, chemicals in there, and it's really quite difficult with that whole mix to sort out what's going on. So, and everything has an impact on everything else. So, you know, one of the things that you were talking about, one of the questions was, what's the impact of chemical recycling on, or AI and robotics, and how it will affect chemical recycling. So the more and more we pull out material for mechanical recycling, we'll leave less and less for chemical recycling in the first instance, because eventually everything that's mechanically recycled will lose its integrity and need chemically recycling anyway. But yes, it's complicated. Okay, so I run the UK Circular Plastics Network. Just a bit of a plug for that before I talk about funding. I'd really like you to join. If you're not a member, it's free. The URL is there, ukcpn.co.uk. And the best bit about it is that we send out a newsletter every month, and that has stacks of information on the events that we're aware of or running, on the funding that's up and coming, you know, information that will be valuable to you if you're looking at the circularity of plastics from any aspect, whether it's design or recycling or end of life, the material choices, etc., etc. You can follow us on Twitter, or you can follow me on Twitter. If I hear about something juicy and interesting, I will put it out there. We've got a LinkedIn group that's about 500 individuals who can contact each other on that, so you can network with like-minded people. We also have a collaboration platform. The URL is there, and as soon as I stop talking, I'll pop these things in the chat box, but I'm not that good at multitasking, so I'll do that later. And that's international. You can put in a little profile on yourself and search for individuals who've got the same, or you know, the gaps, and identify what you're looking for, and contact them through that platform. We are holding a competition briefing event on the 3rd of November. I'll talk more about what that's about, but that's some future funding that's coming up at the moment, and that little red circle's about where to register on the platform. Just one thing I want to say about the KTN, because Jana introduced the KTN and said what we do, but we do a lot, and we can help you. One of the things that I like to give people to do before I have a really long chat with them and signpost is get them to go through our innovation canvas, and that's an online digital tool. If you're thinking of running a project, or even just as your business is at the moment, you can go through this activity and find out, you know, where your gaps might be and where your strengths are. And if you identify any challenges or action points that you need from doing this process, do contact us and we'll see if we can help you with any of those things. That's where to find funding, or the technology, or you know, market information, etc., etc. And we hold lots of events, workshops, we build collaborative partnerships, we hold conferences, we can review your applications when you've done your first draft, and I prefer it if it's as well written as possible before I get to see it, so that I can help you make the changes in the time to get the application in. Yeah, we do pitch fest and all sorts, so just do ask us, anyone in the KTN. If it's not the right person with that technical expertise, they can signpost you to somebody else. Okay, right, on to funding. Now, I think my colleague Ray Chegwin is on the call, so if Jana's going to open up to questions after I've spoken, I'm going to let him answer questions on this one. But there's a current competition open at the moment, which is a pot size of just under 4 million, and it closes at the 11th of November. And it's around waste management, sorting and segregation of waste. And Ray has told me it doesn't have to be around nuclear, so it could be waste and sorting of plastics and glass and metals as well. So I will let him talk about that. But the place to go to check out the information, the scope and the eligibility is in that URL that's in green. And hopefully Ray can answer some questions on this one after me. I mean, my expertise is in plastics, so I tend to look for most of the plastics funding. So I'm just going to show you a couple of slides now that will encompass the stuff that's out there at the moment. So there is a competition that closed yesterday, actually, called Manufacturing Made Smarter. And the reason I bring that up is that I know that the people on the call will be interested in that sort of tracking and tracing, and using robotics and AI to automate your system, make it faster, higher productivity, etc., and be valuable towards making our waste collection system better. Would have been in scope for that competition. And I'm fully expecting that pot of money, where that came from, hasn't been utilised in full yet. So whilst that closed yesterday, in the future there'll be another competition that will probably be similar in scope. So it's worth keeping your eye out for something called Manufacturing Made Smarter. There's a current Industrial Strategy Challenge Fund pot of money, which is the ISCF acronym, which closes on November the 4th, and it's called Transforming the Foundation Industry. So again, if you're into sorting and collecting and increase sustainability and productivity in the foundation industries such as glass or ceramic or paper, metals, that's also valuable to you. And IETF, I'm going to have to put my hands up. I don't know exactly what it stands for, but it's around energy efficiency and decarbonisation. If you're in the plastics industry, any of the SIC codes between 10 and 33, and you're looking to improve energy efficiency or reduce greenhouse gas emissions of an industrial process, which could well apply to recycling, then that's another competition that's open at the moment, closes on the 28th of October. On the bottom there is a URL where you can find all the open competitions. There's generally around between 20 and 30 open at any one time, so it's worth going to have a look there and see if there's anything that will fit your project. And actually, I would definitely say, just by showing these, that you might read the headline and think that's not for me, but if you read the detail, you might find that you're in scope, and that's often the case. So do take a look at that, or ask one of our technology experts in the KTN to sort of point you in the right place. So we don't, as I said, we don't just look for Innovate UK funding. RAP, which is the Waste Resources and Action Programme, which has been mentioned already by those speakers, has a fund available at the moment for textiles recycling. So I know there was a question. I hope the lady that asked it is still on. That's a grant for textile recycling, which closes on the 30th of October. Please do look at it. That is a UK RAP. RAP Cymru, which is the Welsh arm of RAP, also has 2 circular economy funds, and they're open. They don't have any closing dates. They are constantly open, so you can just put the application in any time you like, and then they periodically assess the ones they've got. I think it's on a quarterly basis. They're open until March 2021. Two sizes of grant, a large and a small one, and that's around increasing the use of recycled plastic, paper or card or textiles in new products. So that's worth having a look at. Zero Waste Scotland also has the very last of its circular economy investment funds available, and that closes on the 16th of October. So if you're doing something in Scotland, then do take a look at that one, and that's around obviously reducing waste as well. Right, so the really interesting thing for me and the sort of focus of what I'm looking at that's really, really specific to the plastics community is a competition which is opening on, it's actually opening on the 26th of October, and the competition briefing date is on the 3rd of November, and that's called Future Plastic Packaging Solutions. So do come along to that briefing again, and I will pop the URL in the box in a minute. And that is from a larger piece of funding called the Smart Sustainable Plastic Packaging Challenge. The Smart Sustainable Plastic Packaging Challenge is another industrial strategy challenge fund, and it's a £60 million pot of money, which is being deployed until 2025. So there's been some previous competitions from that 60 million that's opened already. There was a feasibility and industrial research competition earlier in this year and a large demonstration round, and they're currently assessing who the finalists or the award winners for the Enabling Research Fund will be, and that's the university funded activity. There's some information that's out in the public domain which you'll find on our website and who's been funded in the feasibility industrial research, and hopefully within the next couple of weeks or so we'll be able to share the information on who has been funded in those large scale demos, and they are in the space that we have been talking about in terms of sorting of plastic waste. So as I said, on October the 26th we've got the Future Packaging Solutions competition opening. It's a £2 million pot, and projects can be between £50,000 and £150,000 in size, and the green bullet points are the sort of themes that they're looking for, and you'll see the second one down is marking and tracing of packaging to improve supply chain circularity and sustainability. So again, everything that we've been talking about, robotics and AI, would be in scope for that. The URL for registration for the briefing events on the right hand side. And I've been given permission to say by the challenge director of the Smart Sustainable Plastic Packaging Challenge that I can talk about the future funding that's coming. There will be a larger scale demonstration pot of money happening in February of 2021, and competitive R&D, quite a large pot actually of 12 million in March of 2021. And that's going to be a really interesting piece of work, because the kind of things that you've been talking about would be, you know, very applicable, particularly for the CR&D, where you might need to do a lot of analysis and perhaps use a research facility, RTO, or a university. I think that might be my last slide. So yeah, if you want to get in contact with me and ask me any sort of specific questions, or signpost you or help you apply for that fund or any of the others, then please do so. And Jana, thanks for the opportunity to shout about sustainability and the circularity of plastics.
No problem. Thank you, Sally. And I think people would be interested actually in those slides you just had. So it would be good if we can send them out to people as well.
Yeah, I'll make sure Poonam has them, and all the attendees can get them afterwards. I've put the URL for the event in the chat box there.
Awesome, fantastic. Yeah, I feel like my colleague Ray has something to say about the nuclear.
Thanks, Ray.
Yeah, no worries. It's just very briefly, it's just picking up on what you said, Sally, that people sometimes look at the headline of the competition and think, oh, that's not for me. So my plea is to look at the sort and segregate nuclear waste one, but don't go running away thinking it's not for me. What the nuclear industry can do very well is measure radioactivity, and we can do that. What they're looking for is people from outside the sector that can sort and segregate different waste types. The nuclear industry has to sort out plastics and steels, soils, all sorts of different types of materials, and it needs to sort it all out and put it in the right box. So I've learned a lot from this session today. It's been brilliant. I know what a MRF is now anyway, but what this competition is ultimately looking for is a mobile, scalable, transportable MRF that they can take from site to site. And instead of a man, and I'll go back to what Charles said about, we shouldn't have to have these, was it dirty, dull and dangerous tasks that humans are doing? Well, if you think of a dirty, dull, dangerous task in waste sorting, in the nuclear industry, there's a guy in an air-fed rubber suit who's doing this. He's going along, sorting through rubble, measuring it and trying to sort it. So this competition is a real challenge. We're looking for a system, an autonomous system that can sort and segregate waste. Yes, ultimately we'll have to measure the radioactivity and sort it into intermediate level waste and low level waste, but the low level waste needs to be sorted into metals that can be recycled. It needs to be sorted to waste that can be incinerated. More importantly, stuff that doesn't have to go into a low level waste repository, because once it's in there forever. So it's really important to sort the waste out. So any ideas, please contact me. I'm happy to talk people through it.
Excellent. Well, excellent. Thank you, Ray. Yeah, with this, I would like to finish the event for today. Thank you, everyone, for attending. It was fantastic. And I think at this event, the recording will be put online at some point, so we can always revisit it. And yeah, thank you to everyone who attended it and who was on the panel. Thank you.